we have not started training people how to become good consumers of data. I think so that's one of the core skills that everybody will need, right? Because we are all now consumers of information.
Hi everyone, this is Sudeshna from the Abundant Psyche, and you are listening to the Not So Corporate podcast. Here we talk about all of those not so corporate things that make corporate entrepreneurs more successful than their peers. And today I have with me my former colleague, Dr. Bipin Chadha. Bipin has over 25 years of experience in developing advanced analytics, AI, machine learning, simulation, and optimization models, and he uses them to solve challenging business problems for a broad range of industries. As the VP of Data Science for CSAA Insurance Group, he oversees data science, advanced analytics, and data governance functions for the organization. He also holds multiple patents, and he recently published a book called The Agile Machine Learning with Data Robot. I'm so excited to chat with Bipin after quite a bit for more. I think we haven't spoken for a couple of months at least, if not more. And if you want to find out more about him, go to bipinchada.com. We'll dive right into the conversation. Hi, Bipin, how are you?
I'm doing great, Sudeshna. How are you?
Yeah, been a while. I'm so excited to have you on because this week specifically I was talking to the folks about data science as a career. So it would be amazing if we could find out about your data science career, a bit of early, a bit of middle, and what you're doing now.
Sounds good. Yeah, I've had a interesting journey. I started off in engineering, so my background is mechanical engineering. And though early on, like even in my master's, program, I got to work on building computational models of engineering systems. So that's how I got into this space. In the early days, we were writing these models in Fortran, trying to figure out how a system would behave under dynamic conditions. And I really got excited by that. And I really loved doing that stuff. So as I got into my PhD program, I got this opportunity to dive into this amazing space of engineering data, right? So this is again way before all these things were cool, or big data was even a term, or data science was even a term. We were trying to figure out how do you use all this massive data sets being produced at that time by NASA and DoD to look at engineering problems, solve engineering problems. So that's how I got into that space. I went on to work mostly in aerospace defense. That's where this kind of work was being done, worked on multiple DARPA programs and so on in the early days of building models, building wargaming models and so on. And it was always a lot of fun. And then I branched off into doing what we used to call it commercial wargaming back in the day, again, building models to help make strategic decisions. I consulted with many, Fortune 500 companies back in the day. And then, interestingly, around the financial crash is when I decided to move into financial services, because there was, this perceived need to be able to doing these things, look at the broader implications of making decisions. So that's how I came into banking insurance side of things about 11 or so years ago. Built many models, helped set up data science practices as it became the buzzword and the thing to do. So I helped establish that in a few companies and help train people in various methodologies and building the models and so on. So anyway, so that's the journey I've taken over the years. Now with CSA, obviously. So.
That's super interesting. And some people don't realize that the new tech first hits other industries before it hits the tech industry, because other industries are always trying to get that alpha gain from the new tech. So that's super interesting that you pointed out that you got into financial services when the crisis hit. You were using data science in DoD before any of this was cool. So that's super interesting. Bipin, if I ask you about your biggest lesson across while you have worked with multiple industries, what would that be?
There are probably many, as you can imagine, sometimes learned the hard way, but I think being coming from a engineering background, you always think a certain way, and you assume that everybody else also thinks that same way. Or even different industries, they use similar techniques. So for example, in engineering, it's very common that you would first build a computer-based prototype. You were going to design a new aircraft or a jet. You will actually start in the computer, right? You will build small models, you do a lot of iterations and testing. And when you are confident, that's when you will build your first physical prototype. And then you will fly it in a actual wind tunnel, multiple times. Only then you will build the real thing, right? Or deploy a real product. But in many other industries, it's common you build something and you launch it right away.
Yeah.
Or you come up with an idea, oh yeah, let's do this, and then you implement it. So this concept of first testing in a safe environment is actually very foreign to many industries. So that's what was the biggest aha lesson that I learned, was that many other domains, even in banking, insurance, it's very common to go do something and figure out what happens, right? And sometimes it works, sometimes it doesn't, right? We all know
Yeah.
sometimes the horror stories that happen later on, or even in tech. So that was the big lesson that, and that's a big culture shift, right? Because people are not used to thinking in those terms. So when you're trying to, put forward that idea, sometimes people look at you funny or say, I don't know what you're talking about. Why would we do this?
Yeah.
So yeah, so that getting people to accept new ways of doing this, new ideas that haven't been done before in a particular industry, and how hard and challenging that is, right? Was the biggest lesson I learned along the way.
That is super fascinating because I say this primarily because I think in data science, sometimes, especially when we are testing it out on newer industries, which probably don't have as much impact on, like when you are doing data science in DoD, it's defense, right? It's about
Yeah,
life and death and politics. That's high stakes. But sometimes we don't realize that we are putting these data science models out in the world that can affect real people, real societies. And I think
exactly.
that's a really super interesting point that you made about testing and thinking about all of the pros and cons and what all this may or may not impact. So that's really fascinating. And I think sometimes engineering also has something to give to the business and challenge the business as well on, hey, are you doing that? Does your model have bias or not? Especially these days, we are
Mhm.
talking about health tech. And if you have run the entire sample on a particular demographic, your model may or may not scale very well to another set of population. And I think
Yeah.
that's fascinating.
And also, beyond even scaling, there are always, whenever human systems are involved, there are other second order effects and consequences that are not obvious when you're building the model. Like I get involved in building a lot of the models, and we do, yeah, all the testing, and we have out of sample data sets that we do validation, cross validation, and testing. And most people believe that, hey, yeah, we tested it, now we are done. And I said, no, you're just beginning.
Mm,
You just tested whether your model is making good prediction. You haven't tested what is the impact of your decisions on your ecosystem. It's the really testing that's missing still big time, right?
yeah.
As you can imagine, that we go and deploy these models, and sometimes we get surprised and we wonder, hey, why did this happen? And I don't want to name any names, but you can go look at, even in the past year, there have been fairly spectacular failures that have happened in different industries. Again, I won't name any names,
Mm,
where people were using models and that lead to billions of dollars of losses. And people get surprised as to, hey, how could have this happened? But to me, I'm surprised that it doesn't happen even more often.
exactly right. That's and when it's billions of dollars, I almost say that's the better outcome. Sometimes it's billions of lives, and
Yeah,
we
yeah.
have half the times no clue about how we are impacting the world around us and how it impacts us back. If I take a step back, how do you define data science, Bipin?
I define it as techniques and methods to help experiment with data, to look at different hypotheses and what the different implications are. And I know that definition is probably not the standard definition, but I feel that if we're going to put the term science in it, that scientific aspect of having hypotheses, of testing and experimentation has to be a big part of it. Yes, data is obviously a big part of it also,
Mm.
but I think it's these other aspects that many times we don't pay as much attention to. And I believe if we're gonna keep wanting to call it science, then I think bigger focus will need to be on experimentation and hypotheses and testing of those hypotheses as we go forward.
Awesome. And you recently wrote the book on Data Robot. Can you give us a bit more on that?
Yeah, so actually I wrote that book, interestingly enough, to make some of the points I'm making. So I wanted to lay out a methodology where we look at the problems more holistically. And also when we build a solution, I feel we need to look at that solution also more holistically. Right? But what happens is today with the current way we do things, we spend so much of the time in things like data cleansing and writing the Python code and so on, that we get buried into that detail and we lose the big picture. Right? So I wanted to give people a roadmap on how do you do that, and then how do you use these emerging technologies like Data Robot, and there are other tools out there that can do some of the grunt work for you,
Mm.
right? So now your mind is free to explore these other things that we are
Mm.
missing right now. So I saw a interesting combination of those things happening because I don't like to offer solutions where people have to do now 3 times extra work. I'm already very busy. Thank you very
Mm.
much.
Mm.
Don't tell me to do more things. So I like to bring a solution where say, okay, I'm also making your life easier and giving you less grunt work to do. Now you're free to think about these other things that you previously did not have time to think. So it was really about how do you understand the problem? And yes, you will build some models, but then when you are ready to deploy those models and make decisions off of them, how do you understand the implications? How do you test those implications? And do this entire process, hopefully a lot faster than what you're doing otherwise. So I'm using, Data Robot as a tool, which at the end of the day, it's a tool, right? Like many other tools that we might use um, effectively as we move
Mm.
forward. Many people feel that, hey, these tools are going to replace us or replace data scientists. And that's another point I make in the book that I do not see that at all.
Mm.
Because there is so much things that smart data scientists with all the skill and knowledge they have, they could be doing and should be doing, but they are not doing because they are too busy writing and debugging Python
Mm.
code. So I feel that we need to get to this next level of working to become better data scientists and provide better value to the businesses we are in and to the society in general.
Mm. That's amazing. I was just about to ask you that there's this growing concern amongst people about, is data science a good career because there are these new tools like Data Robot and H2O and whatnot. But you bait me to it. You are already saying that no, data scientists won't be replaced. So, Bipin, for anyone who's trying to get into the field with the context of H2O or Data Robot in the background, what
Yep.
skills do you think they should be focusing on the most for the next few years?
Yeah, so actually, some of those skills are the good old skills and cliche skills, being curious about stuff and think about the problem. And that's what I believe is kind of missing today. So there are a lot of people somewhat mechanically cleansing the data, and throwing that data on a particular algorithm or a deep learning algorithm and get a prediction answer, and that prediction looks great, and all that is amazing. So I'm not saying that stuff is not amazing, but in my mind that's just a small part of data science. The big part of the data science is being a scientist, and that has not changed for hundreds of years. Being a scientist is to be curious about something. You dive into something, you experiment, and you try things out, and you look at the data you're generating, and then you try to make sense of it. It's really that part that's very hard to automate.
Mm.
Maybe 50 years from now, somebody will automate that part. I don't know. But at least today, that's very unlikely. For anybody who's getting into that right now in that career, I think you are pretty safe if you have those skills and if that's your interest. If you're curious, you're interested in digging, problem solving, you're interested in solving interesting challenges and making a difference, then that's the data science career. And hopefully, with these tools, some of these barriers of having to know or being a very good Python programmer hopefully should be reduced. I envision that that barrier to entry will get reduced. Now it's more about what can you do with it.
Yeah. I think it in a few years' time, we hopefully will have data science tools as we use Excel or comes integrated in the system as Excel. I say a few years, it might take more than a few years,
Yeah,
but
it might take, and yeah, for most part, yeah. Will there always be a need for people with great programming skill? Yes, that's not going to go away anytime soon. You will still have many problems where you need to write all that code by yourself because it's so new, or a new technique is being talked about. But for a vast majority of the problems, I see no reason where most people who have that kind of a thinking mindset, that data-driven mindset that I call it, should be able to use these advanced tools to solve and dive into these interesting, challenging problems.
yeah. So, Bipin, do you think people would need statistics or a background in statistics lesser as well with tools like Data Robot or H2O?
No, I think that some of those things will remain. So knowing, and actually it's also even broader than statistics, because even statistics does not by itself give you all the necessary skills to investigate data, right?
Mm.
Some of the methodologies are obviously more advanced statistical methods. You often hear about many of these paradoxes that exist in statistics. There's a Simpson's paradox, and then there's a Bergson's paradox. These are things that trip even fairly sophisticated people,
Mm.
right? But they are beginning to get more and more well known, and these things can be taught to people, I think, rather easily, right? You don't really need to be a PhD statistician to understand some of those things. But it's just that we have not started training people how to become good consumers of data. I think so. That's one of the core skills that everybody will need, right? Because we are all now consumers of information.
Mm.
Not only in our work life, but also in our personal life. You are being bombarded with a lot of ideas and sometimes even conflicting messages because people are now beginning to manipulate data to show you something. They will show you a graph that looks like, oh, very nice. With actual data, it has been manipulated to give you a completely wrong impression
Mm.
and to fool you into making bad decisions. And I don't need to name anything. We all know what's going on in the world. Even if you go look at the past couple of years, there are many examples of how large segments of population are being tricked into believing something that's completely wrong.
Yeah.
Right? So I see definitely a need for people to become more savvy data consumers and not to be fooled by. So that skill, I think, will become more important, and that's something will have to be taught. Now, once you're able to understand the data, now all this modeling stuff can come along and make things better. But any of these modeling tools by themselves, again, You can build a great model and still be fooled by data. Is what I'm saying. That skill,
Yeah.
will have to become, more important as we go forward.
Yeah, 100%. I mean, I have seen so many cases where people almost start with the conclusion and then
Mhm.
manipulate the model to get to the conclusion they want to get to. And that's not hypothesis testing. That's
Yeah.
that's just
Yeah, and we know that particular problem is as old as statistics itself. That the famous quote of, lies in statistics is also as old as statistics. So
yeah,
yes, you can use statistics, data, and modeling to come up with very bad conclusions.
yeah.
And that's what hopefully we can teaching people and giving them skills so they don't get trapped in that.
Exactly. And you mentioned about problem formulation and how that can help people think through some of this. Can you talk to us about that a bit?
Yeah, one of the classic things. So this is another big lesson I learned over the years is that most people are very bad at formulating problems. Right? So when they come to you, hey, we have this problem, solve it as an engineer or a data scientist or as an analyst. Even when somebody comes to you and say, hey, company is having this problem. In the early days, I used to take it on the face value that, oh, this is the problem. Your customer told you this is the problem, so let's solve it. What I learned later on, sometimes the hard way, is that was almost never the problem.
Hmm.
The problem actually was sitting 3 layers deep, and you had to ask a lot of, probing questions. And I learned of this technique called 5 Whys and Lean Six Sigma training, which I know many people are probably familiar. Right? So it's again classic issue that unless you ask the why 5 times, you're not even close to understanding the problem. So that's what I mean. And there are now more advanced methods, so they're like methods from systems thinking and system dynamics that help you look at your system more holistically and therefore find the actual problem. Right? That's driving the symptoms. So most people will come to you with symptoms,
Hmm.
and you have to know that and learn that. And this is not something that you learn automatically in school, right? So that's the thing. They don't teach you how to get to the real problem. But that's what experience and learning is all about. You figure out over time that, okay, this is how it is, and you have to get to the root of the problem before you have any hope of solving the problem, right? And a lot of people have said that in many different ways. There are quotes from Einstein. If I had, I don't know the exact code, if I had 10 minutes to solve a problem, I'll spend 9 minutes thinking about the problem and formulating it. And I think it's the same idea, right? That it's hard to do.
Hmm.
Your instinct is to jump in and start solving it, even while somebody's explaining it to you. But you have to sit back and think about it. And again, and those skills, they're very hard to automate, right? You cannot expect something like a H2O or a data robot to solve that problem.
Hmm.
That has to come from a person. And I think that's where smart data scientists will shine if they understand how to do it. Then it's a matter of, yeah, you also know Python and you can use H2O and data robot to build a model. Yes, that's then the easy part.
Yeah. That's so true. The hard part sometimes is just being still, taking a step back, and just taking the time out to understand the problem, like you said. So that's fascinating. If I move on to the next thing, Bipin, what is the technology that you are most excited about in the next few years?
So in terms of, again, data science type technologies, I think there's work being done to better understand causality, right? So some of those techniques around being able to build more federated distributed models. So that's another area of interest for me. Also tying in of many of the data science techniques with simulation.
Mm,
That's also an area that I've explored quite a bit over the years because I see that there are problems that data science methods, today what we call data science methods, mostly machine learning. So I should probably be more specific. Machine learning methods are not very good at solving certain problems, which are actually very good for simulation oriented techniques. So merging of those two disciplines and building models that leverage both, that's very exciting to me. So again, so those are some of the areas that I like to watch and see what's happening in those techniques. And then so there are obviously other technologies I'm sure will keep evolving, making things more distributed, and also increasing that what we call the general intelligence. Right? Today the models are very specific, but we all know human mind is able to generalize. So potentially techniques coming from neuroscience with better understanding of how human brain works and applying those principles is probably another very interesting area.
I'm fascinated by neuroscience and all of that, but I'll be honest, I'm a bit skeptical around the generalization of intelligence, but that's just
Sure,
me.
sure.
But if I go back to the first bit that you mentioned around simulation models. So, Bipin, if I was to ask you about how near or far the digital twins and ML coming together are, how far away is that, do you think?
Actually, it's interesting. In many cases, it's already here, right? So I was mentioning to you about my work in the early days. So I actually worked on some DARPA programs where we were tasked for building a digital twin of the entire platform, meaning, let's say, a destroyer, right? So Navy said, yeah, we know how you know how to build ships, but we want you to build and deliver a digital ship to us. This is around year 2000, more than 20 years ago. So we actually worked on a program and actually we delivered a digital ship to Navy almost 20 years ago, right?
Wow, that's
So
fascinating.
yes, it was hard to do and we were inventing things along the way, but some of the underlying techniques and technologies are already there. I think the key thing missing is, like I said, that desire to test and explore before you deploy. So why would you need a digital twin? Digital twin is only useful if you can use it to make good decisions ahead of time and test out your decisions, right? That's what a digital twin will be good for, right? That you can test your new idea, your new product, your new marketing strategy on the digital twin of your system and realize what will work, what will not work, and you can try 10,000 ideas on it, right? Unless you are thinking about doing those kind of things, a digital twin is useless to you,
Yeah,
right?
but I
So I think
think
in
that,
many industries, it has not been built because people are not used to thinking in those terms.
yeah, I think that could have quite massive implications on corporate strategy or strategy consulting
Absolutely.
projects, because that's essentially what we deal with in corporate strategy anyway.
Exactly. And like I said, and in a lot of the consulting work I was doing, as I was explaining to you in my earlier intro, we used to call them commercial war games. But basically these were digital twins of somebody's business, whether it was a mining company or an energy company. And typically companies where they were struggling with these massive decisions, right? If you're going to open a new mine, that's billions of dollars of investment. So you worry about it, and therefore you paid somebody to build a digital twin to play out the scenarios, as you can imagine. But that same idea, can be applied in any industry, and companies can save massive amount of money by not suffering the bad consequences of certain decisions. Now, will it catch everything? No, but it can definitely improve the probability of success, or it can reduce the probability of failure in a company's strategy. So I think, yeah, technology is mostly there. it was hard to get data in the past, which is now much easier now, right? We have all these data lakes and data models and so on. So getting data is even easier today. So building a digital twin in today's date is actually relatively easy. It's more the will and the mindset that's missing.
Yeah, and I wonder if it's somewhat the knowledge as well, because there are probably not many people in the world who are thinking about those two or three things simultaneously.
Yeah, that's true too. Yep, yep.
Brilliant. And you mentioned to me earlier that the technology you think won't survive the next decade is landline phones. No chance?
Probably not. That's the only thing I can think of. I know even technologies, like completely getting rid of them takes a long time. They all have long tails. So I think that may be the one that, could go away potentially.
Oh God, I thought it had already gone away when my parents finally decided to hang up their landline. And my parents are like slow to the point. They are
Yeah,
probably the last people to get onto any sort of technology.
yeah,
So,
yeah. And that's why I said, yeah, I didn't go because I still know some people who use their landlines. So
okay, all the best to them in that case. Finally, Bipin, can I ask you, what is that one not so corporate thing that we don't talk about enough in corporate life that you have found to be the most impactful in your career?
I think the people and the relationships with people is something I found to be one of the most important things. And I know we pay lip service to it. It's still not given as much attention as it should. So, for example, working at Essential, one of the best things I remember is all the relationships and the friendships I had with people like you, right? So here we are a year later talking and chatting, and that's the best part in my mind. Like all the years I have worked, just talking to old friends from 20, 30 years ago and chatting about stuff is at least what brings me the most joy. And I know it doesn't get talked about and we don't pay that much attention in organizations on that aspect of it. I think that's where I see opportunity to become. Maybe we were more human before and we are becoming more machines now. I don't know. So I think we need to start becoming more human. This little guy showing up in the middle of our call, and
Yeah,
you are apologizing. You should not be. Hey, this is part of normal life. This is what life is. So
this is what
to
life
be
is.
celebrated. I think it levens up a meeting when a kid comes walking by or even a cat jumps on the table. I think that's great. There's no need to apologize for that. So this is really those kind of things I'm talking about that I think we need to bring back more of. And it's great. I think the things like Zoom has given us this opportunity for that to happen. Otherwise, you would never see that in your office.
Yeah, that is correct. And yes, for any of you who's catching the podcast, if you probably jump onto my YouTube, you'll see how my son basically dropped himself on the podcast uninvited. But yes, I completely agree, Bipin. I think relationships are what ultimately move the world forward, move businesses forward, move all of us forward. And it's almost a bit too corporate to talk about this in corporate life. You're so right. But ultimately, I think that also speaks to the vulnerabilities of being human that actually connect us to each other. And that's been amazing. That's been such an honor to have you on, Vipin. Thank you so much for
Yeah,
being on the show. And for those of you who are still with us listening, go on to bipinchadha.com. You can find more of Bipin's work on there. And if you liked the episode, please drop a comment. And if you really liked it, drop a subscribe. Thank you so much, and I'll see you the next time. Just
sounds
stop the
great.
recording.